Alright, so when you multiply like bases, what do you do to the exponents? Add the exponents. Fantastic, alright? When you divide like bases, what should we do to the exponents? We should subtract them. Alright, so our homework on dividing last night, you should have gotten, bless you, c squared times d to the 12th power. Alright, and then 9 divided by 3 is 3, and that would be x squared b cubed.
I got 3b to the 7 and x to the 7.
Taters, it says subtract the exponents. 9 and 3 aren't exponents. What are those called?
So you leave them alone?
Coefficients. Take a point. Alright, for our homework for this guy, we should have, it would end up being g to the 9th divided by e to the 9th and f to the 5th. This has a 1. 10 minus 1 is 9.
Oh my. I'm so done.
No, it's okay.
Negative 9 and negative.
I got that right.
When they're on the bottom, when you flip them to the bottom, it becomes a positive.
I just need to remember.
Do we need to do another one like that?
No,
I think we need to do another one like that. From the moans and groans we got on that. Okay, now what we're going to do is you are not going to write, you're going to write the problem on your paper, but you're not going to write the answer on your paper yet, okay? So you're going to write the problem down. Then you're going to discuss it in your group, and you see how you have the whiteboards out? You're going to write those, well, unless third period actually put them up. They're in the bottom drawer. So you're going to write on your whiteboard the answer. Is everybody with me? All right, so here's B. And they should have put them up because I asked them to to clean up their tower.
What about a marker?
I'll bring it to you.
If you get it right, you get it.
All right, so this is our problem. You are only going to write it down on your paper, and then you're going to discuss in your group, and then we're going to write the answers on our whiteboard. Does everybody understand?
Yes.
Okay, so you still need this on your paper. We're only writing the answer on the whiteboard.
Oh.
Is that A12 or just?
A to the 12th power.
Okay.
Thank you.
Vinculum. Alright, so the way you do this one is first you have to divide your coefficients. So the biggest number that goes in a 10 to 15 is 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So you don't change where the numbers are. Y'all just changed where the numbers were and you don't do that.
How did you do that?
Okay, 10 divided by 5 is
2,
15 divided by 5 is
3.
I don't have to find a 5. I'm saying, where did you get the 5?
maybe I just said the biggest number that goes into 10 and 15 is.
Oh, I didn't hear that part.
Where are you at? Alright, what's 7 minus 12? So where's it going to go? On the bottom. What is 3 minus 5?
2.
And where does it go? And 5 minus 1 is?
4.
Boom. That's all you do. Do we need to do another one?
Yeah.
Okay, we're doing another one.
Down like the steps that you said.
Yes. Alright, we're going to write C under here. Again, go ahead and write the answer down on your paper. You may now write the answer down on your paper.
We're not doing the board no more?
I really don't know what word you said.
We're not doing the board anymore?
We're going to do the board on C, but we're writing down the answer on our paper for B.
Okay.
Is that better? Are you sure?
Is it negative? A little bit.
No.
Okay, well, it looks like a negative sign. It's an equal, but I
Do you think you'll be better after we work the next one out? Okay, she's just ignoring me.
Hey,
Wait.
sister beat me for last night.
Wow. Where you at?
I'm sorry?
This
This says on top 16 g to the 7th h cubed I cubed.
Thank you.
On the bottom it says 24 g squared h I to the 17th. Alright, so hopefully you guys should have gotten 2/3 because the biggest number that goes into both of those is 8. 16 divided by 8 is 2. 24 divided by 8 is 3. And then that gives you g to the 5th h squared divided by I to the 14th.
You do one more just like that. That wasn't like in here. That was like not.
Okay, we'll do one more. Alright, don't write this one down on your paper.
Right away.
Board. Tater tot.
Write it horizontally. Yes, write it vertically.
Okay.
25 and 20 reduce to 5/4. 17 minus 41 gives you e to the 24th. 2 minus 50 gives you f to the 48, and then your g's cancel.
Can we do one more?
No.
We gotta move on.
Yes. I need.
We really need one more?
Yes. No.
Right. Do you need one more, or do you want more because you want more?
I need it.
Okay, well, we have more problems to do. You need another problem?
Yes.
Okay. We're going to do this one together.
Okay.
Okay? So everybody just watch. If I say,
Oh, that's 50. 25.
all right, why would it be 2/3?
25 goes into the back.
Okay, does everybody see I got that? I divided both of those by 25.
Yes.
Okay? And then what's 4 minus 10? Negative 6, so where does it go?
Bottom. 6.
Okay, what's 7 minus 25?
Negative 19. 18.
Negative 16.
Negative 8.
18.
18.
Negative 18.
I just said.
All right. And then what's 2 minus 4,000?
398.
That's 3,998.
Negative 3,998, so it goes on bottom.
98.
That's it. That's all you do. Okay?
Thank you.
You're welcome. Ready for the next section of your homework. All right, so when you multiply like bases, what do you do to the exponents?
Multiply them.
Listen to what I'm asking you. Listen to what I'm asking you. When you multiply like bases, what do you do to the exponents? It's crazy what happens when you listen, right? When you divide like bases, what do you do to the exponents? If you get a negative, what do you do? Alright, when we do power to a power, we? No. Alright, so this becomes x to the 28th. Because 7 times 4 is? Alright, this becomes c to the 30th. Why did it become positive? And this becomes 1 divided by e to the 45th power.
I got all those right.
Yay! How do we feel so far? Do we need to do some more like this, or are we good? Open! Distributing! Alright, so hopefully potatoes. Hopefully whenever you did this problem, you did 2 to the 5th power. And what'd y'all get when you did 2 to the 5th power?
Wait, no. power.
just leave it.
2. 2 to the 5th power.
Okay, guys. 2 to the 5th power is 2 times 2 times 2 times 2 times 2.
32.
Are we sure?
36.
Okay. And, Blair. 32. And then it would be A to the, and then B to the,
15.
woo!
You look so weird.
I feel weird. Feel like, nope. Nope. Alright, so for this guy, I got 1 divided by, jazz hands if you got it right. Yay! That's almost a class full of jazz hands. That's exciting. Do we need to do another?
No.
Are we sure? Do we need to do one with a coefficient out front? Do you understand that you have to raise everything in this to that? Are you sure? You could write it out to the side here. Maybe. Over here. Oh, I'm sorry. Ma'am? Oh yeah, we're going to finish. You can write it over here. So let's write that. When, I'm going to write it to the side. When distributing a power to a power. Now, do you multiply everything or do you multiply each exponent by what's on the outside?
Each exponent.
Okay, so multiply each exponent by what? By the outside exponent, right? By the outside exponent.
I have a question.
Yes.
Are we gonna have one?
Yes.
Because I was gonna ask it, not this.
Yes. We have a minion after this.
Oh, you said a second.
All right, so what do we do with the coefficient? It says when distributing a power to a power, multiply each exponent by the outside exponent. Yes, okay, so let's write that. Raise coefficients to the outside power. Thank you for pretending to write. Who do you think?
Only Andrew. I have a question.
Yes.
Is it ever gonna be like a coefficient like on the outside of the parentheses? Do we raise that?
Only what's in parentheses. Alright, turn it this way. Alright, we have 2 more things to talk about and 1 remember thing to do, and then we're going to get our minion. So, what we need to talk about today is what happens when you have a 0 exponent. Zero exponents. Does anybody remember what happens? Christine? It's fantastic. Take a point. It turns out to be 1. So if I have 5 to the 0 power, what's that going to become? 1 every single time. No matter what it is, it becomes 1 every single time. If I had negative 15 to the 0 power, what would that become? 1. If I had... What was that, Avery? Oh no, be about it, baby.
I was just saying 1.
You don't know what I'm going to do.
How about
If it's heart to the 0 power, what is it going to be? Unless you're like Avery and you have no heart.
Hurt.
Or by 24.
Alright, so what could we say is our rule?
Whenever an exponent is raised to the 0 power, it's 1.
That's
Alright, so anything, a shortened version of that, anything to the what? 0 power is what?
1. Wouldn't you include the TH from 0? First power, second power.
The zeroth?
Yeah.
No.
For real?
Yes.
I've always said that.
Oh, okay. That's
Yeah.
scary.
Like I say 0 period. What the heck?
No.
Is that not a thing, y'all?
Zero period.
What if I said rainbow to the 0 power?
I am shocked. It's shocked. That's funny.
You should put that on a test. Rainbow to the
I'm still shook, for real.
No.
Alright. Now, when you multiply like bases, what do you do to the exponents? When you divide like bases, what do you do to the exponents? When you have a 0 power, what does it become? It equals 1. When you distribute a power to a product, what do you do? Multiply what? Alright, when you have a power to a power, what do you do? When you have a negative exponent, what do you do?
You flip them.
We are going to, well, one of the last two things that we're going to write, we're not actually going to cover in detail today. We're going to do it on Monday. But I want to show you what it is. So what have we not talked about so far as an exponent?
No clue.
No.
Decimal.
I don't know what you said because you're whispering at me. We're getting to that later in the week, but that's a good thing. Okay, we haven't talked about that. But what else? We've talked about whole numbers. We've talked about positive numbers, right? We've talked about negative numbers, right? We've talked about 0,
Decimal.
Can you divide it?
Decimals.
fractions. Not decimals, we won't have decimals up there, but we will have fractions.
She said that like
From the 2/3.
Yes. I think I'm going to stop giving points when y'all ask.
After we don't have to.
Not as an exponent.
Oh.
So fractions as exponents. And since we are not covering it in detail, we're going to do it on Monday. We're going to write C, page 45. But I'm going to show you a baby example. So give me a fraction.
2/3.
Let's do 1/3. There's a reason we're going to do 1/3. Hey. Okay, awesome. Alright, so do you see how our fraction is our exponent? What do you think we would do with it? Don't say add, subtract. Don't. Nope. Mm-mm. Mm-mm. I just said don't say those. Hmm? No. No. It starts with an R.
Reduce.
No.
R-A.
Radius.
ratio.
Radiation.
You're just saying things that, what is happening? It turns into a radical. Who knows what a radical is? What's a radical?
I just removed the word. I don't remove the definition.
We all remember the word.
Oh.
What is it?
Our numbers or not?
Mm-mm.
Oh.
If
If it's
they're
positive.
Mm-mm.
That's
don't know what you're saying.
I'm thinking about this.
3 times x and
If it's great. Radical.
No.
Variable. Greater than.
Mm-mm.
I don't know last year.
It's called a radical. It is a thing we do.
Do you flip the fraction and
Kind of.
x to the third time?
No.
1 over x.
I think I remember.
We're not over anything because we're not cows.
You flip the fraction. You put like 1 then like.
Nope.
You put the 3 on top.
A mixed number?
Make it 8.
It's a radical. You turn it into a radical. What is a radical?
Oh, no, not good.
Divide.
What's a root?
So like a square, and then it goes in the. It goes
Finish your
in the
sentence.
curriculum.
Oh,
I don't know what to say.
Write it for me on the board.
Right, a square.
Square. What would you like?
Square root of like
Show me what it looks like. Show me what it looks like.
Oh.
You have boards. Show me what you think it looks like.
Check mark looking for.
Write it on your board. Show me what you think it looks like.
Oh, man.
Look at you guys go. Now, where do you think that 3 would go?
And
Right here. Oh, I remember this. It goes like on the outside right here.
Where?
Yeah. No, right here. Where the S is. Right raise it to there. Like it goes up like that.
That's not it.
wouldn't it be like
Asbury.
Y'all are real close. Where would it go?
On the top. Where? Like if you get the long division.
The 1 is on the
Would it go
top.
right there on that line?
Write it. You have a board. Write it.
Does it go there? Asbury, inside.
Would it go like
Inside.
Write it. You're just drawing lines. I don't know what that is. Is this abstract math? Move your hand, child. No.
No.
But pick one, baby. Pick one.
like this?
Right there.
Nope.
It would go. It would.
Look at you go. Van got it. Take a point. All right. So it would become
That's what I put it.
the cubed root. It goes inside the mullet. No, baby. I don't know what you was writing. It goes inside the mullet like this. Now, where did the 1 go?
On the top.
Where?
It disappeared. It was like
On
no.
the top of the
front.
ribbon
It's
is
in
curriculum.
Oh, dividing.
No.
Above it.
To the right side.
Draw it on your board.
No.
Tell me where the 1 went. Draw it on the board. Kind of. Kind of. No, Avery. Yes. This is your 1 right here. It's hanging out. So, what if it was a, alright, what if I said,
She left.
No, I was scared, y'all. She was right there. That's all I had to with.
it's still recording.
I'm putting 2. We're talking about
Okay, what if I said this?
the 2.
Wait, let's write it on your board. Baby, I can't read that at all. Nope. I can't read that. Look at you guys go.
Let me see.
Fantastic.
Hey, let me see.
I can't read it. I can't read where the numbers are.
You put the bigger number.
Oh, you put the big number in there.
We are going to on Monday. Fantastic.
You want more of
It's
that?
called the denominator.
Yes. The denominator always goes right there. So we're going to talk more about that on Monday. On Monday. No more.
Why do you still put the 1 there?
This, okay, so the 1 is invisible, right? We just understand that there's a 1 in things. This is how I end a radical. So, say for instance, you had a problem that said x squared, y to the 4th, and then z cubed. The way you denote that this z is not under the radical is you end it. And that z is on the outside.
Okay.
So remember, this is called a radical. It's also called a root. What is this bar right here called?
The vinculum.
Fantastic. Take a point. If you said vinculum, take a point. All right, so the last thing that we're going to write is remember. Alright, so what if I said 4 squared? What would that become?
8.
No.
I mean 16.
Okay. What if I said negative 4 squared? Like that, what would that become?
No, 16 still. Let's go to
Negative 4.
And what if it was written like this? Then, no.
Negative 16.
Then it's a negative 16.
Yeah. What? I don't know.
You said fraction, but I think you meant negative. I don't know what you're trying to say.
How would it be?
You really meant a fraction? Oh, no, Tater.
Like, you know how we were flipping it?
Yeah, that's only when the exponent's negative. So if the negative is in parentheses, it becomes a positive. If the negative is not in parentheses, it stays a negative. Okay? So this weekend you have a minion. I'm sorry. Would you like more homework than that? Okay, then we're going to stop with that negativity.